supervisor is Dr. Andres Bota, our past president for SASD. The structure of my presentation, I'll give you just some background and introduction, and then I'll show you the methods, discussion, and conclusion. The reason why there is no result on this paper is that it's still currently a working paper. It's in early stages, part of my PhD work that I'm doing. So there are no results at the moment to present. So what I will present in this paper mostly will be the methodology that I'm applying in the research, and then discussions on the tools that I'm using or going to be using in the research.
Presentation mode on your side.
Sorry?
Christopher, I think they're asking, is your presentation in presentation mode on your side?
Yes.
It's because we only see still the presentation without being in presentation mode.
Okay. On my side, it's on presentation mode.
Do you have two screens sharing at the moment? Maybe you share the other screen? Is it possible?
Can you see it now?
We only see background, but I still see your slides. Like on the left-hand side, all your slides are showing. That's what we are seeing. So
and
I'm
if I
thinking
do this,
maybe if you reshare just the other screen.
Okay.
It might be that, Christopher. Sorry.
Let me try to reshare again. Can you see the full screen?
No, I think what's happening is when you share, you should choose the screen, not the presentation itself, because if you click share and you click on the presentation, it shares this only one file where it doesn't show your screen. It actually shows just this one. But let me check with the room itself, like if it's okay, like, but yeah, I'm not sure what they see. But from my side, I'm still seeing the presentation as is. If you show your screen, you could maybe see the shared screen instead of just the file.
Okay, let me try something else and see.
So sorry, Christopher. It's not the worst.
Because on my side, I'm actually putting on the
presentation mode, right?
On the presentation mode.
And if you click share, look at the options you have. Look at if there's a screen. Choose a screen. Don't choose the presentation.
Okay.
When you click sharing.
So on the share.
Yes. When you go share, click on the screen that you want to share and not the file you want to share.
Okay.
Try one more time. If that works, that doesn't work, I guess it's not the biggest train smash.
Sorry, what we can do on our side is actually present your slides and then you can take us through it. I think that might be easier.
Okay.
Can we do that for you, Christopher?
Okay. In terms of speed, it might delay in terms of speed, but it's still okay. You can do that.
You can just tell me next, and then I'll get to.
Okay.
To
okay, let's do that.
Okay, let me just project quickly. Okay, you
Okay.
can go.
Okay, go next. 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 Okay, so the just behind a bit. Okay, it's okay. You can leave it there. So the objective of my research is to research on how to propose to develop a framework for designing or for flexible mining systems. So when we are talking of flexibility, we are basically talking of a system that will be able to adapt in face of uncertainties or unpredictable changes that could happen in the future. So you'll find that in large-scale systems such as manufacturing, energy, space, and so on, these are complex systems that the decision process for selecting a technology is affected by many factors, such as your socio-economic factors, human and behavior social systems, the markets in which the products or they are trading in, then environmental and ecological system, as well as the developments in the technologies. So the challenge that we have is how somebody want to plan for technology and select the right technology that will be able to be flexible, considering also that most of these large systems, they have to plan it over a long time horizon, say 20, 30, sometimes 50 years. You know, maybe steam turbines could be 50 years in future. The technology that you select now is expected to be operating then. Next. Next. So my approach, I would want to use system thinking approach in approaching this problem, because these large systems, obviously, they are system of systems. There's an issue of connected nature of the technology problems, and also literature is actually showing that the applying of systems thinking in this kind of projects is not very much operationalized in most of the systems. People don't apply systems thinking when they are selecting their technology or in developing a lot of the other technological systems. So the importance of system thinking is that it gives you a holistic perspective of the systems, and it acknowledges the relationship between the components and between the different systems. So I'm going to be applying the systems thinking tools, and the tip of the iceberg is one of the most important ones, and some of the tools like causal loop diagrams and system archetypes. Next. So in terms of my method, I'm going to use a systemgram just to highlight to you how I approach this. The main issue will be, the first thing is to understand the technology structures in the large system that I'll be analyzing, and then understanding the dynamic behavior of that system, then reducing the complexity using the system modeling tools. So basically from there, I'll then be able to develop a framework for selecting the technology. So because it's still a working paper, I'm going to concentrate mostly on technology structures, understanding the structures and the dynamic behaviors. So this is what I'll just give you a brief in terms of the approach that I'm using in the paper. Next. So in terms of structure, for a large system, you will find that because most of these large systems, they are socio-technical systems. They involve the technology as well as the social and human aspects of the system. So when you are looking at these systems in terms of structure, you have to consider all this, including the external systems that interact with the system that you are designing. So a lot of the tangible system might involve your technology, but there's a lot of intangible system that even when you are selecting that technology, you have to take that into account. Next. So the first thing that I am in trying to understand the structure, I did a hypothetical copper mining system, and we need to make an investment decision in terms of the technology. So using the causal loop diagrams, I could be able to pick the different feedback loops that are available in such a scenario. For example, the main issue that could be driving this is that there could be an increase in demand of the commodities that are required now for the transition to the cleaner energy environment, which has become topical these days. So because of that, there's an increase in demand of copper, maybe to make electric vehicles and other technologies. Now, if you're a copper miner, how would you now select the technology that you need? So if you look at the first reinforcing cycle, you realize that the commodity price might start increasing because there's an increase in demand and there's a shortage of that metal in the market. So when there's a shortage of that metal, these are things external to the business. Now, internally, the business now has to make a decision to select a technology. So people debate now whether to increase their capacity or not to increase their capacity. But in increasing their capacity, they have to select a technology that will do that. But normally that decision doesn't happen immediately. So there's a delay. People have to decide now what are the factors to consider before you can select that technology. So that technology decision takes quite some time. It can take a prolonged time, maybe a year, 2, or even 3 years before people decide to invest in a technology, because they are not sure of the dynamics of the market, how that market behaves. So eventually a decision is made and people invest in technology. But by that time, we are also having reinforcing and balancing dynamics that are taking place. So by the time maybe that decision is made, the demand of the commodity prices decrease. Maybe there were many of the mines that came in at the same time and started producing enough copper, so the price drops again. So by that time, when your technology comes into play, you are now maybe faced another dynamics that your business is now affected in terms of profitability and all other things. So this is the loops that one will be grappling with in trying to make that decision. Next. Next. So in now trying to understand this dynamic behavior, one of the tools that I'm thinking tools that I'm going to use is understanding the stocks and flows. If you take a typical mining process, you normally have your reserves of ore, which we assume there's enough that they are not ending, but then you have to select your technology that will do the mining. So it controls the extraction rate that you can do for that particular mineral that you're extracting. And then your stocks will probably involve your rock that you have mined. After you've taken off that rock, which they call the ore, you then have to go to take it to a processing plant that processes and extracts the metal from there. And then what you need to sell to the market is your metal. So what I'll be doing now is trying to understand the dynamics in terms of stocks and flows in a mining environment between the stocks that you are going to be holding as well as the stocks of your metal. So these are the key dynamics that I'll be looking in. So we'll need to determine how I will model my stocks and flows diagram. Next. Now in trying to understand this behavior, what I could model in terms of the stocks and flow probably will refer to the internal systems. But there are also a lot of external systems that are external to the system that the mine itself might not have control, or the system, the large system might not have control over. If you can go to the next. So I try to depict this in a what I would call maybe a policy structure diagram, because of a lot of non-linear relationships between these different elements. I'm now trying to compare the feedback loops that we have, the causal loop diagrams, as well as your stocks and flows. So you'll find that I'm trying to depict on this picture what are things that are external to the business and those that are internal to the business. So the internal, we're talking about the technology that you're going to select for metal processing and for mining. And then you also have the metal that you're going to be selling to the market. So all these stocks and flows dynamics can be controlled maybe internally, but there are external factors that affect those decisions. For example, in terms of technology, the type of technology you're going to choose, it's going to depend on what the technology manufacturers have in the market. So it would determine the type of technology you have. But that also is also affected by the quality and grade of ore that is being produced. But that quality of ore and grade is not something that you can control. But obvious mines, they've got a way of determining what ore is available. But as the mines are starting to mine, you find that a lot of the mines are now deep. If you look in South Africa, I think it's got one of the deepest mines now, 3,500 meters down. So that's depleting ore reserves affective in the technology that you are going to be using. This also affects now in terms of, you might now need to have more mines to be able to meet the demand of these new metals. The problem with that now is a lot of exploration has to happen. When exploration happens, you are now going to go into communities where you are now going to interact with new communities. And now there are socio-economic policies that is going to affect you in terms of labor, labor markets, the legal, political issues, the license to operate issues start to come into play. There's also the market itself with its own dynamics, reinforcing dynamics, where there's the difference between supply and demand. So, but now we are trying to make a decision for a 20-year project or a 40 years project. By the time maybe you make that project, the type of technology will probably have changed. So how do you make those decisions? So this is where now systems thinking approach comes into play. And trying to balance all these different elements cannot just work using simple operational research tools and so on. You need to have a system thinking approach and consider all these factors in making a decision. So currently my study is now at data collection. So now I'll be interacting with a lot of the different elements that I've put in here and try to collect data before I can start modeling now. But this is basically the approach that I'll be using. Next. So basically in this paper, I was just trying to illustrate to you how we can use systems dynamics, system dynamics and system analysis tools, thinking in terms of approaching a problem like selecting a technology in a large scale system. And I'm going to be using mining as my case, but I'll be comparing with other different large scale systems to say, how do you approach this issue of technology? Consider the complexity of technology, the fast changing technologies that is now taking place, and all the socio-economic interactions that have to take place when you are making such a decision. So basically that is for me today. Thank you.